Unit 3.2, Lesson 5, Mass to Mole Conversions. In order to accurately track amounts of compounds, it is often necessary to convert mass to moles. Molar mass values allow us to convert back and forth between grams and moles. As a result of this lesson, you'll be able to convert the number of moles of a compound or an element to mass in grams. You will also be able to convert the mass of a sample in grams into moles. The relationship between the mass in grams of a substance and the number of moles is proportional. The proportionality constant K is equal to the molar mass and is different for each substance. The molar mass of a substance is used to convert between moles and mass. Moles cannot be measured directly. Instead, we measure the mass of a substance and then convert the mass to moles using the molar mass. To convert mass to moles, divide the mass in grams by the molar mass. The relationship between the number of particles of a substance and the number of moles is also proportional. In this case, the proportionality constant K is Avogadro's number, 6.02 times 10 to the 23rd. Note that particles can refer to atoms, ions, formula units, molecules, and so on. To convert from moles to particles, multiply the number of moles by Avogadro's number. In the first example problem, we are asked how many moles of arsenic are there in a sample with a mass of 125 grams. So we know that we're dealing with an element, arsenic, and we know that we have a 125 gram sample. First, use the periodic table to determine the molar mass of arsenic. So arsenic has an atomic mass of 74.9 atomic mass units. That means that the molar mass, which is the mass of 1 mole of arsenic, will be equivalent, 74.9, but the unit now becomes grams per mole. Next, divide the mass of arsenic by its molar mass. Why do we do that? We're starting with 125 grams of arsenic. I want to convert the unit of grams into equivalent amounts of moles. So in order to cancel out these grams, I must have grams at the bottom of this conversion fraction. And I'm trying to convert it into moles of arsenic. So looking at my given information, you should notice that there's only one piece of information that relates moles and grams, and that is the molar mass. So according to the molar mass, there are 74.9 grams in every mole of arsenic. Once you simplify this, solution is 1.67 moles. So there are 1.67 moles of arsenic in a sample with a mass of 125 grams. In the second example problem, we are asked how many moles are present in a 10 gram sample of calcium chloride. First, we need to use the periodic table to determine the molar mass of calcium chloride. Just like the previous problem with arsenic, we are going to use the periodic table and the average atomic mass. However, because this is a compound and not a single element, we must be very careful of any subscripts, parentheses, or coefficients that might affect the amount of atoms present in our molecule. Calcium chloride is made up of 1 mole of calcium, for every 2 moles of chlorine. Each mole of calcium has a molar mass of 40.1 grams per mole. Every mole of chlorine has a mass of 35.5 grams. However, there are 2 moles of chlorine present, so this is going to get multiplied by 2. Once I simplify these numbers, I'm going to total them up, and that will give me the molar mass of calcium chloride, which is equal to 110.9 grams per mole. Once I have the molar mass, I'm going to divide the given mass of calcium chloride by its molar mass. Just like in the previous problem, that's because I am starting with a 10-gram sample. This is the information I've been given. I have 10 grams of calcium chloride. In order to convert from grams into moles, I must cancel out the unit of grams and leave behind the unit of moles. The only piece of information that I have that relates those two values is the molar mass, which states that we have 110.9 grams in every mole of the substance. Once I divide those two values, I have 0.090 moles. That is how many moles of calcium chloride are found in this sample. The third example problem is slightly different from the first two. In this case, we are given the number of moles of magnesium. We have 3 moles of magnesium, elemental magnesium, and we want to know what is the mass of this sample in grams. However, just like the other problems, we still first use the periodic table to determine the molar mass. Because this is an element, a single element, this is extremely easy. Numerically, we just use the average atomic mass from the periodic table for magnesium, which is 24.3. And because it's the molar mass, 1 mole, it's that many grams per mole of magnesium. Now, this time, we're going to be multiplying the number of moles in our sample and the molar mass. To understand why that is happening, we use a similar method from the first 2 example problems. We write down our given information. What we know about our sample is that we have 3 moles. We have 3 moles of magnesium, and I want to be given a mass in grams. So I need to multiply it by a conversion fraction that is going to cancel out the moles of substance and leave me with an equivalent value in grams. Once again, the only given information I have that relates grams and moles is the molar mass, which I determined to be 24.3 grams for every mole of magnesium. In order to simplify, you are going to be multiplying these 2 values together. When you do, that gives you 73 grams. So a 3 mole sample of magnesium would have a mass of 73 grams. To wrap up this lesson, how are moles related to mass? In order to convert moles to mass, multiply the number of moles by the molar mass. In order to convert mass to moles, divide the number of grams by the molar mass.